How's it going, everybody? And welcome back to our Nexus dashboard series. In this video, we're going to go ahead and get the MPLS VPN set up. That's only going to take a very short period of time to do. And then I'm going to go ahead and get Cat AK19 connected to AK15 and all this stuff right here. We're going to get all this configuration up and running, and then the PE to CE routing stood up. It'll take a couple minutes for that as well. And once that configuration is all done, we should start to see route exchange between the two different VXLAN fabrics. So with that being said, let me go ahead and get out of the way, and we'll go ahead and get this configuration underway. Configuration-wise, it should be pretty straightforward. I'm going to run OSPF in the core. So I'm going to start on CSR25 and just work my way around to CSR28 and all that good stuff that goes along with it. So I'm going to go ahead and say, if I do show IP interface brief, I'm using 10 nets across the board. So I'm just going to type in router OSPF1. I'm going to type in the router ID is going to be 10.0.0.0.25, and the network of 10.0.0.0, 0.255.255.255, area is 0. I'm going to type in MPLS LVP autoconfig. And then I'm going to basically do show run section OSPF. And I will, oh, that is not what I wanted to do. One second. Go ahead and, this will speed the process up. Any of you that are studying for your CCIEs or maybe a CCNP NRC, this is a good way to get comfortable making modifications to your routing environment. So we're going to go ahead and get that in play. And then on 27 and then 28. Get that in play, and then 29. And just like that. Okay. So now that that's all done, it'll take a couple of moments for that to come up. 26 is going to start appearing, then we're going to see 27, 28, and 29 shortly thereafter. And while I'm working on that, 29, I'm going to go ahead and configure BGP. So it's going to be 25 and 28 are going to be our PE routers. So it's going to be router BGP. I'm just going to put in here 65100. And I'll type in address family IPv4 unicast. And then address family VPNv4 unicast. And then I'm going to, I'll type in, so there's my adjacencies up to both of those devices. I'm going to type in neighbor of 10.0.0.25, remote AS of 65100. The update source is going to be loopback 0, and then address family VPNv4 unicast. And I'm going to, it automatically comes online when you do that. So I'm just going to go ahead and make this 28. And then address family VPNv4 unicast, activate. So do show run section BGP. There we go. So BGP is, oh, I didn't activate this one. Forgot about that. There we go. I'm going to save that config. I'm going to go to 25 now. And we're going to go to router BGP 65100, address family IPv4 unicast, address family VPNv4 unicast, and it's going to be neighbor of 10.0.0.29, remote AS of 65100. Update source is going to be loopback 0, address family VPNv4 unicast. And as you can see, it activates right away. And I'll do a show run BGP. And I will basically just take this config and copy and paste it into 28. and that will form that peering for BGP as well. Once that's all done, which it pretty much is, that BGP peering is up. Do show BGP VPN v4 unicast all sum. We can see the peering is up, but there's no routes being exchanged yet. What I will go do is I'm going to set up a BGP peering between 28 and 29, or sorry, 28 and 30. So what I'll do is on 28, I'm going to create a VRF, and I'll just create this VRF definition, and I'm going to call this customer 1. The RD is going to be, in this case here, I'm going to say, I'll keep it simple, 1:1. And the address family, IPv4 unicast. The route target for this, I'm a big proponent of doing a, I don't like doing the both for the import and the export, but I'm going to go do that. And the reason why I'm going to do both, route target both, and then the variable is going to be 65100:1. And there's that. So what that'll essentially let me do is that'll let route exchange happen back and forth. So we're going to continue that process here. So the next stage of the process, now that I've got the VRF created, is to go to interface gig 2 and give it an IP address of, and I'm going to give it like a semi-public IP. So I'm going to give it 1.28.30.28. I like to do a semi-public IP, meaning that it's not an RFC 1918 address, only because the fact that it provides a little bit of a different look when you're doing like trace routes and things like that, even though there's really no requirement that says you have to do that. And we'll do that. And then I'm going to go to router I made a mistake. So this is going to be VRF forwarding customer 1, and then we're going to have to go reapply the IP address, and then I'll type in router BGP 65100 address family IPv4 VRF customer 1, and it's going to be neighbor of 1.28.30.30 remote AS of 65012, and I'm going to do the same thing on CSR 30. No VRF on this one though. So interface gig 2, IP address here is going to be 1.28.30.30/24. I'm going to no shut that guy. And then I'm going to go to router BGP 65012, or actually, hold on, do show run section BGP. Yeah, that's right, because this is also my my external device outside of my fabric. So router BGP 65012. I'm going to type in neighbor of 1.28.30.28, remote AS of 65100, address family IPv4, and I'm going to go ahead and activate that. After a moment or so, we should see the peering come up, and then once it comes up, if I log into 28 and do a show BGP VPN v4 unicast summary, oh, I'm sorry, show BGP VRF customer 1 IPv4 unicast summary. Show BGP VPN v4 unicast all summary. What is going on? Do show IP interface brief. Do ping 1.28.30.28. Show IP interface brief. Oh, that would help if I would enable the interface. Oh boy. It's like, why is this not coming up? You're right. Okay, there we go. So now the peering is up. If I do a show IP route VRF customer 1, I should see 10.2.10 and 10.2.11 showing up, which is exactly what I'm looking for. If I go to CSR25 and I do a show BGP VPNv4 unicast all summary, oh, I know what I didn't do. Okay, my fault. I didn't do route reflection. So let me go ahead and just add that in real quick. Neighbor 25 route reflector client. That'll do a resync, and then let me do the same thing to 28. That'll do a resync. Okay, my fault. My bad. The little things in life. Summary. So what should end up happening now is we should see a show BGP VPNv4 unicast all summary. We're getting 2 routes in from there. They're IBGP over here. Oh, the VRF's not configured. That's right. So let me go ahead and configure the VRF on 25. So what I'm going to do is on 28, I'm going to show run section VRF. I'm just going to grab this config right here because I want to make sure that it's good to go. 25, we'll go and configure that. We'll configure the VRF first, and then now if I do show IP route VRF customer 1, we should see the routes. Same thing with do show BGP VPNv4 unicast all summary. We're going to start to receive routes because now we have a VRF, we have a import policy set, so we'll be able to receive the routes. So the next stage in the game here is that if I do this, we'll see that the peering is up, doing what we expect it to. The next stage is to go and configure 25 talk to 19. We're going to do a simple one and go from there. So the process of this is pretty straightforward. So we're going to go to gig 2. We're going to say VRF forwarding is customer 1. The IP address here will be 1.20 or 19.25.25/24. I'm going to say no shut, and then I'm going to do a router BGP 65100, and then address family IPv4 VRF customer 1, neighbor of 1.19.25.19, remote AS of I think of 65. I think I'm using 6511 here, so I'll do an IBGP peering. That should work. You know, I'll use 6519 just so it's easy to remember, and then this is 6511, so this will be eBGP between the two, and that'll be just fine. So now on 19, even though I don't have this configured yet, and then cat AK15, let me just do a show run section BGP. Okay, let me go ahead and we'll go to interface gig 4. IP address here will be 10.15.19.15/24, no shut, and then router BGP 65011, neighbor of 10.15.19.19, remote AS of 65019, address family IPv4 unicast, and then we're going to go ahead and activate that. I'm going to save that config real quick, and then I'll just leave cat AK19 to be configured. Host name is going to be cat8k19. Interface gig 1, IP address here will be 10.15.19.19/24 mask. No shut that. And then interface gig 2, IP address here will be 1.19.25.19/24 here as well. No shut. And then router BGP 65019, no BGP default IPv4, neighbor of 10.15.19.15, remote AS of 65011, and then neighbor of 19.25.25, 25, remote AS of 65100, address family IPv4. Go ahead and activate that peering, and then this peering. Momentarily, we should see a route exchange from both. Hopefully I didn't screw anything up. Make sure 25's interface is up. Yep, sure is. Do show BGP IPv4 unicast sum. I'm receiving 6 routes. Perfect. Do show IP interface brief. Do ping 1.19.25.25. What's up with 25 here? Do show run section BGP. Okay, that all looks correct. Do show run interface gig 2. Do ping 1.vrf customer 1.19.25.19. Okay, so that's the issue right now. Is we have an issue there. 25, so it's a /24 there. Do show run interface gig 2. 19.25.19. Yep. I'm going to troubleshoot this. I'm going to pause the video and I'm going to monkey with this for a little bit to see what's going on, and we'll go from there. So this should be working. All right. Well, pauses are very helpful in situations like this. So on CSR25, this is a CSR 1000V to do show ver. So the thing that I'm thinking the problem is incompatibility between the CSR 1000V and the CAT AKV. So I've got CSR 25, and then we have the CAT AKV up here on 19. This is a CAT AKV, and I'm thinking that there's an incompatibility here because I can form a BGP peering and ping from CAT AKV, CAT AK19 to CAT AK15, no problem. Everything works great. But when I try to connect to 25, it's a no-go. So what I'm going to do is, through the beauty of video editing and pausing and all that other happy fun stuff, I'm going to repause the video. I'm going to basically take a show run of all these devices, and I'm going to blow away all of these CSRs and replace them with CAT AKVs and do an MPLS VPN with that. So what's actually going to be kind of once I do that, it'll take a little bit of time to spin them down, bring in new devices, and swing all the connections over and all that type of stuff. It'll take a little bit of time to do that. Really, the only benefit that we have from doing this is going through and connecting them together, connecting DC2 to DC1. That's really the only point to doing all of this. And one thing that I could do to eliminate this complexity of having an MPLS VPN in the middle, which for me it's easy because I've done so many MPLS VPN labs from studying the service provider track and spending time in the SP world, that it's a piece of cake to do. So one thing that I could do would be to spin up a new SWIT, a new CAT AKV, and then connect 19 and 20 together and bypass this. That was another thought. So I think just for the essence of time, and to make this, just to finish it without having the coolness of an MPLS VPN, is to just do basically a back-to-back connection. So connect a border to a border without anything in the middle. So, and normally what you would do, so let me talk just briefly about the architecture of how that would come into play. A border device, a a Nexus leaf switch that's been given the border role is typically going to be connected to the outside world that doesn't cross a DCI. That's typically the way we do it. A border gateway is specifically used for interconnecting two different VXLAN fabrics. So it's a border gateway. It's got the capabilities of doing multi-site. Not that you couldn't do multi-site on a border switch. The idea of a border is to bring you into and out of a VXLAN fabric that isn't going across a DCI to another VXLAN fabric. That is the border gateway. So sometimes it's a semantical difference. I'm not sure if that's even a word, but so what I think I'm going to do in the interest of time, just to get this done, and it'll only take me a couple of minutes to do this, is I'm actually going to go blow away this MPLS VPN, and I will go ahead and just connect, I'll create another AKV here, connect it to this cloud, connect Nexus 12 to it, set up a new peering, all that good stuff, and then we'll go through that. And that will really just allow us to do the interconnectivity that we need to set up. Once that's done, the coverage of the content that I wanted to do is then complete. So the next stage from there would be to go through and I would begin releasing videos to YouTube at that point. The other thing that I could do is, that I want to test out, is bringing up Palo Firewall and things like that to see what my options are for bringing that online. So what I'm going to do with you guys in the video, just to show you how you would do this, I'm going to go ahead and bring a new Cat AKV in, which I really should start leveraging the Cat AKV. And I'm going to say two of them. Oops. It's going to be Cat AK, and then I'm going to I'll deploy two of them, and then I'll give it 6 interfaces, and like that, just so that they get a number. So we're going to have that, and I'll move this guy over here for the temporarily, and I'm going to connect Nexus 12 to gig 2 on this box. The beauty of Eve Pro is being able to add things on the fly without having to power something down. And then what I'm going to do is 57 is going to connect to 19, like so. And then all that I will have to do, let me bring up secure CRT for that. Move this off screen real quick. Is I'm gonna bring this management interface, I'm gonna connect it to gig 8 or gig 6, excuse me. And then I will power him on. And I'm going to, I'll just stop these boxes. Just because the fact that they're, at this point in time, I don't feel like messing with it. I really do believe it is a functionality issue between the devices. Delete selected. That'll clean this up. And then we'll bring on Cat AKV 2057. So let me clean this up a little bit. And now that that's done, I'm going to go ahead and start him. And then there's that. So I'm going to let that guy boot up, and then we will go from there. I will bring you guys back in once he's booted, and I will go through the process of onboarding him into dashboard. Alright, so the router's up now, so I'm going to go ahead and begin configuring it. There's still a little bit of behind the scenes stuff going on, so I'm going to type in no service config. And then I'm going to go to interface gig 6, and give this an IP address of 10.255.1.57/24. That'll hang once it comes online. And okay, so there we go. So the next thing for me to do is host name is going to be cat8k57, and then I'm going to go to username is going to be ndfc privilege level 15, secret is password, and then line vty 0 space 4 login is local. I'm going to save that config for the moment. I'm going to log into dashboard. Go ahead and refresh this. Log into dashboard. We're going to go to DC2. Go to here, switches, actions, add switches. It's be 10.255.1.57. This will be a iOS XE box, cat AK there, and then NDFC, discover switches. It should be able to find it pretty easily. There it goes. We're going to go ahead and add that, just so that we can do the remaining of the work, just so that we have a device that we can peer Nexus 12 to, because that's what we need to do. We need to get a peering from Nexus 12 to cat AK57, and then cat AK57 will be able to peer to cat AK19, and we'll be able to go from there. Alright, we're going to close that out. I'm going to go over, close this out, because now that the cat AKB is there, we're in good shape. I'm actually going to go ahead and say actions. I should be able to just delete the device, delete switches. It might squawk at us and say, yeah, you can't because there's already something attached to it. So I'll come back to that later and do a little bit of cleanup, but essentially that's what I'm going to eventually go and do. Let me go ahead and pull up this connection here, and on 57 we're going to go to interface gig 2, I'm sorry, interface gig 1. IP address here will be 10.19.57.57/24. No shut the interface, and then cat AK19 interface gig 3, so do show IP interface brief, interface gig 3, IP address here will be 10.19.57.19/24. We just want to make sure that we can talk back and forth. That's really all we care about. And as long as we can talk back and forth, I will be able to give that connection its operational information that it needs. There it goes. So do ping 10.19.57.57. Perfect. Then underneath here, router BGP 65019, neighbor of 10.19.57.57, remote AS of 65012, address family IPv4. We're going to go ahead and activate that peering. Nothing's going to come up right away, obviously, but we're going to go ahead and go to router BGP 65012. It's got to match what CSR30 is configured for. We're going to do a neighbor of 10.19.57.19, remote AS of 65019. That should form a BGP peering here more materially. It does. Do show IP BGP, and we're learning a bunch of routes across, which is exactly what I want to have happen. So now if I come over here to dashboard, I close this out, I go back to DC2, I go to links, and I create a link, create. I'm going to go interfabric, VRF Lite, source fabric is DC2, destination fabric is DC2 iOS XE, source device is going to be N12, destination device is cat AK57, source interface is going to be E11, into gig 2. So it'll be E11 to gig 2. It's going to be 10.12.57.1/30 to 10.12.57.2. And then we're going to go ahead and click on save. And then I'm going to go over here to VRFs. Click on the VRF. Drill down to, actually, we'll take that back. Switches, N12. Drill into N12. VRFs, VRF attachments. We're going to go ahead and click here, edit. We're going to go ahead and we're going to extend it, attach all. Gig 2, we're going to use that. We're going to go ahead and save it. And then we're going to go deploy that. Actions, deploy. So we're going to get a E114, E11, get .1Q2. So that's gonna. So I just want to make sure we have the right VLAN ID. It's going to be .1Q2, and we're going to go ahead and cancel. We're going to deploy that config. Now what I'm going to go do is on here. I'm going to go to interface gig 2, no shut. We'll give that a couple of seconds to do its thing. Interface gig 2.2, encapsulation.1Q2. IP address here will be 10.12.57.2/30. Do show IP interface brief. Okay, cool. So it's already there. So do ping 10.12.57.12, or sorry, .1. Cool. So router BGP 65012, neighbor of 10.12.57.1, remote AS of 65,002, address family IPv4, and then just like that, do show IP BGP, and we see traffic coming across already. So we see the 10, 2, 10, 11, and 10 and 11. If I go over here to Nexus 3, show BGP, VRF, DC1, VRF prod, IPv4 unicast, I will see term with 150. And we're going to see traffic coming across. So when you see this line right here, that's a multi-path path. It's got multiple ways to get there through 10.6 and 10.7. So basically what it's telling me is 7 and 8. So now the true test would be this, since I've got route exchange. I'm going to go over here to this guy here. I'm going to pull up server 30, so do server 31 because he's attached to that. And show MAC address table dynamic. So there's an interesting thing that happens when you end up having to reboot all the devices, is sometimes you run into duplex issues. So it looks like all these guys, well, only that one seems to be having, 34 is having a problem, 33, 31, 35, not so much, 39, yeah, anything that's attached to a Nexus switch. So I'm going to have to make a couple of adjustments, and I'm going to make it on 1. I'm going to go here to interface gig 0/0, type in no negotiation, no duplex full, and that should get rid of the CDP issues that I'm seeing here. So we're going to do a do show interface gig 00. Duplex is full. Okay, so do show ARP do ping 10.1.11.1. Make sure I can ping my gateway. Can I ping the other gateway? I can ping the other gateway. Can I do ping 10.2.11.47? That's over here. And I can. So I pinged from 31 all the way over here. So if I do a trace route to 10.2.11.47 numerically, I hit my gateway, then I jump up here. Let's go minimize this real quick. So the path that I take is I hit my gateway, I hit 715, I hit, that's going to be this path right here, and then 815, it tries to go, it ECMP flows this one, because here 7 and 8 are both learn the route through this way. Then I hit 1519, then I hit 1957, the 57 jumps across to 12 on hop 6, and then I'm in the fabric at this point here, and then I jump from N12 to N10, and I get to where I've got to go. So that just proves to you that I have end-to-end communication inside of VXLAN Fabric. The thing is, it's not a stretched network. That's the key thing I want you guys to remember here. So operationally, it's doing everything we expect it to do. So we're in pretty good shape. If you guys have any questions, please leave a comment in the comment section below. And that, ladies and gentlemen, is a wrap. I am going to save all the configs. I will save them in a Notepad docs, and then I will upload them to the Google Drive file. If you are interested in, if you have the membership, if you click the join button, you'll be able to download the configs and this topology. I will power it down and I will export it for you. I think it's got to be powered off in order for me to export it. I'll do that. I am going to be doing some testing. I'll test out the Palo firewall, see if I can join it. So just in case anybody's curious on how that would look, I'm going to make this video go a little bit longer than I intended. And we've already verified operation. So